Hey there, Sam! Now before you continue to watch this series, I will assume that you already have a good understanding of PHP, Composer, MySQL, and the concept of MVC. If any of those sounds a bit unfamiliar to you, you might want to read up before continuing. I have attached a few resources in the description below, so feel free to check them out. So here I've got a fresh installation of Laravel, and if this is the first time that you're working with a web framework, this might look a little bit intimidating to you. If you're unsure on how to create a new Laravel project, simply go to your terminal and type in Composer, create project, Laravel/Laravel, and your project name. This command will create a new folder with the same name as your project, and it will generate all the files required for us to run Laravel. You should see something pretty similar to what I have here on my screen. If you want more information on how to install a Laravel project, simply head to the documentation and browse to the installation guide. And again, the link is in the description. Okay, back to our code editor. We see a lot of files and folders here, and they do look quite scary. We have app, bootstrap, config, database, public, and all other kinds of scary stuff. But don't be scared, you don't have to learn them all at once. Let's do a quick rundown on the folder structure in Laravel. Laravel is built based on the MVC software architecture, so we'll be seeing a lot of MVC-related terminology in the files and folders. Let's start with the app folder. So the app folder is where we'll spend 90% of our backend development time. This is where we put in our main app logic and all the code related to our app. Next, we have the bootstrap folder. As the name suggests, this is where Laravel bootstrap or set up our app. You don't really need to touch this folder. It is just one of those folders that is required by Laravel to work properly. The config folder stores all the configuration of our app. Things like database connection, authentication driver, mailing provider are all defined in here. The database folder contains all the code related to our database, and that includes the migration files, which is how we define our database schema. In other words, how we define our tables in our database. We also have seeders and factories in our database folder, and they are responsible to populate dummy data in our database. The public folder contains static resources. In other words, the public-facing HTML files, JavaScript, CSS, or images. Everything we put in here will be accessible by the public, so make sure you don't put in anything sensitive in here. The resources folder is where we put in all the front-end stuff. These are the source JavaScript and CSS files that are yet to compress and minified. The length folder is where we put in a translation mapping for our app. The routes folder is where we put in all of our app routes. This includes the web routes for the user interface, API routes for incoming HTTP requests, channels for WebSocket broadcasting, and console for CLI commands. The storage folder is where the app stores things like cache, log files, images, and other generic files uploaded by our app user. The test folder is where we put in our unit test and feature test, and the vendor folder is a directory created by Composer where it puts all the project dependencies in here. And that's about it for the folders. Let's go through the files now. The files that you can see here are mainly configuration files. I'll go through the important ones here. The editor config file is just a file telling your text editor on how to format your code. The .env file is where we store all of our environmental variables. The git ignore file tells Git to untrack all the files and folders listed in here. The reason why we want to untrack files and folders is because these files normally contain sensitive data, like your credentials or API tokens, or just simply too big to push it to our Git repository. styleCI.yaml is the configuration file for styleCI, which is a software that auto-formats your code. Artisan is Laravel's main command line interface. This file is the main script that runs the CLI. We're going to be using it very frequently in this series, so stay tuned for that. Composer.json is required by Composer to manage our project dependency and also store other metadata. Similar to Composer.json, package.json is required by npm for a similar purpose. phpunit.xml is the configuration file for us to run PHP unit test. Server.php allows Laravel to run a development web server without using external web server software like Apache on Nginx. And finally, Webpack.mix.js is a wrapper around Webpack for us to easily bundle our front-end assets. So that's a quick overview on the files and folder structure of Laravel. I hope that makes things a little bit less scary than before. Now let's talk about how Laravel handles incoming requests. The index.php file in the public folder is the main entry point of the whole app. Let's look at what's going on here. The first thing it does is to check if our app is in maintenance mode or not. Maintenance mode is the mode where we stop all of our web services in order for us to do maintenance work like fixing a bug or upgrading our software. If we're not in maintenance mode, Laravel will then load the autoload script provided by Composer to load all of the PHP classes in our app. Once that's done, we're importing an app instance from app.php inside the Bootstrap folder. Let's take a look at what's going on in there. So here we're creating a new application instance. You can think of this app instance as a giant object that contains all sorts of information regarding our app. For example, the base path of our app, in other words, the location of our project in the computer, or information like how many users are currently logged into our app, all of the HTTP routes in our app, the environmental variables and the configuration details, and other app information. This information is not typically handled by the app instance directly. Instead, we create classes for which Laravel code services to take care of this information for us. For example, if we want to know how many users are logged in at the moment, there will be an authentication service class living somewhere in our app that handles all the authentication logic and information for us. However, we still need a way to connect this service to our app instance. And Laravel does this through something called the service container. You can think of the service container as a big box attached to the app instance, and we will put all the services that we want inside this giant box. Let's visualize this to make this more concrete. So here is our app instance, and attached to it is a giant box where we call it the service container. And in our app, we would have a lot of services. For example, an authentication service that handles the user authentication, a routes service that configure and provide us information about the routes in our app, a storage service that takes care of all the file system operations, and lots of other services. Now, in order for the app to interact with these services, we need to put these services inside the container. In Laravel terms, to bind the service into the container, so the app instance can interact with these services. Now, there are two ways to bind a service into the container. One is to call the bind method directly from the app instance, which we'll see later. And the other way is to use something called the service provider. The service provider is basically a class that tells Laravel on how it should bind a service inside a container. It is much more powerful than calling the bind method from the app instance directly. We'll learn more about service provider in more details in the upcoming lessons. Alright, now let's look at how we can bind a service into the container from the app instance directly. So there are two variants where we want to bind a service into the container. One is to call the singleton method from the app instance, and the other one is to call the bind method. With the singleton variant, there will be only one service instance throughout the whole app. So that means every time we try to instantiate an object from this service out from the container, we're always going to get the same instance of the service class. So here in this file, Laravel has bound 3 services into the container using the singleton variant: the HTTP kernel, the console kernel, and the exception handler. If we want to use the bind variant instead of the singleton variant, we just need to call the bind method from the app instance. With the bind method, when we try to instantiate a service class from the container, we'll get a new instance every time. Alright, once we have bound the 3 services, Laravel simply returns the app instance from this file. So in summary, this file simply creates a new app instance and bind 3 services to the app's container. Let's go back to our index.php file, and as we can see, immediately after importing the app instance, Laravel called the make method from the app instance. The make method is how Laravel resolve or instantiate a service class from the container. So here, we're simply getting a HTTP kernel instance from the container. In software engineering, kernel means the core of a software. So the HTTP kernel here, you can think of it as an object that does all the heavy work and connects all the puzzles together for our application to work. The kernel takes in a HTTP request, which is represented by the code here, and generate the response internally, which will be included in the HTTP response to send back to the client. We then call the send method to send the HTTP response back to the client. The file ends by calling the terminate method on our kernel instance, and this method is responsible to shut down the app by calling the terminate method in each middleware. If this doesn't make sense to you, don't worry. We will talk more about it when we learn about middleware. And this is it. This is an overview on how Laravel bootstraps itself and takes care of the incoming request. There are certainly a lot of magic involved in here, especially the kernel class, and that deserves a video on its own to discuss more about it. That's it for now, and make sure everything in this video makes sense before moving on. Key takeaway for this lesson: the index.php file in the public folder is the main entry file of Laravel. The service container is a giant box that keeps app services together. It allows the app to interact with the services. A service is just a fancy word for classes in our app. The app needs to bind a service to the container before resolving it from the container. You can think of binding as putting a service into the box, and resolving as taking out the service from the box. Singleton service can only have one instance. A kernel is the core of an app that does all the heavy work for us. That's it for now, and I'll see you again in the next video. Hey there, Sam. So in the last video, we talked about how Laravel handles an incoming request and sends back a HTTP response by using the kernel. But what's inside the kernel anyway? Let's find out. And now we're in the kernel file. On the first glance, it looks pretty scary. We have middleware, which is an array of classes. And then we have middleware groups. And again, an array of middleware grouped by a key. By default, it only has two groups, web and API. And scrolling a little bit further down, we have routes middleware, which is basically key and value pairs of middleware. So what is going on here? Before we move on, we first need to understand what is exactly a middleware. Middleware, to put it simply, is just a function that runs before the request hits our router. Middleware is one of the MVC core components. If you're not familiar with MVC, I highly recommend you to watch my other video where I talked about MVC in details. The link is in the description. And here is a brief explanation on how middleware works. Suppose the right-hand side is the server environment. When the HTTP request first came in, the request will first pass through a series of middleware before the request hits the router. And the router will then pass on the request to the other components inside the app. A middleware is just a function that contains logic to either modify the request or act as a security guard to check whether the request should be allowed to continue to go inside our app or not. Let's go back to our code. In Laravel, middleware is in the form of a class. Just by looking at the class name, we kind of know what these middleware are doing. These middleware, as described in the documentation, are global middleware that runs through every request. Let's look at a few intuitive ones here. For example, the prevent request during maintenance middleware would not allow any request to pass through if we are in maintenance mode. The trim strings middleware would cut off any blank space on the left and right hand side of all the request fields. And the convert empty strings to now, as the name suggests, will convert empty strings in a request to now. And now let's learn how to create our own middleware. Middleware in Laravel is just a class. The easiest way to create a middleware is to use the php artisan command. Let's go to our terminal and type in php artisan make middleware and followed by our middleware class name. And just for demonstration, I'll give it a stupid name. I'll just call it say cheese middleware. The middleware creator will be located in our app folder, http, middleware, and say cheese middleware. Inside the file, you can tell it's a very simple class with just one method. Code handle. The handle method will contain the logic of the middleware. And it has two arguments, request and next. Request is a representation of the incoming HTTP request. And next is a callback function to call the next middleware. Because middleware is a series of security guards in our app, if we don't call the next callback function, that means the current middleware has failed and our app will block the current request to prevent it from moving further into our app. So here, just for demonstration, I'll dump a string when the request passed through our say cheese middleware. And we'll go back to our kernel.php and put our middleware at the very top of our middleware list. Let's try our code. Let's go to the terminal and run php artisan serve to start a development web server. Go to our browser and we see hey cheese as part of our response. Now let's see what happens if we don't call the next function. Let's go back to our middleware. Instead of returning a result of the next function, I'm going to return now. We'll go back to our browser again, hit refresh, and we see an error. What happened here is that the handle method in the middleware should either return another middleware, which is the result of the next function, or a HTTP response. So if we don't want to move on to the next middleware and return a JSON response, we should return a new JSON response object and pass in a payload. So back in our browser and hit refresh, we now see our JSON response inside the body. Now just to show you the next function is actually calling the next middleware, I'm going to go back to kernel. And trust proxies is the next middleware in line in the middleware series. So let's go in there and override the handle method, and I'll dump another string. So now back inside our cheese middleware, if we call the next function, we should see hey trust proxies inside the browser. Let's give it a go, hit refresh, and there we go. And if we don't call the next function, we'll no longer see our hey trust proxy string. Let's go back to our browser again, and we're back to before. And that is middleware in a nutshell. Now that you understand more about middleware, we can go back and talk more about the kernel. Inside the kernel file, we have three middleware-related properties. The middleware array, which is the global middleware. The middleware groups, where we can group middleware under one key. So the web middleware group here would represent all the middleware that we see inside this array. And the same applies to the API group. Once we created this group, we can then assign a group name to our routes, which you'll see later when we learn more about routes in a future video. And for the routes middleware array, we can assign a middleware alias to a certain middleware class. For example, the authenticate middleware class has an alias of auth, and authorize has an alias of can. So once we have given a middleware an alias, just like the documentation described here, we can assign them to middleware groups or use them individually in any routes. The throttle request middleware has an alias of throttle. So if we go back up to the middleware groups, we can see it being used inside the API group. However, the alias looks a bit different here. It has a colon and a string API. So if we put a colon after any alias, whatever comes after the colon becomes the parameter to be passed on to the handle method in the middleware. So in this case here, we're passing the string API as an additional argument to the throttle request middleware. So if we look inside the throttle middleware, we can see inside the handle method, the string API is going to pass as the max attempt argument. Alright, let's move on. Now I want to talk about what the kernel is doing behind the scene. Let's go back to our kernel and we'll navigate to the base HTTP kernel class. The primary function of this class is the handle method, because it is what being coded inside the index.php file. So what's going on inside this handle method? The main thing to look after here is this send request through router method. Let's take a look inside it. And the documentation here says that this function will send a given request through the middleware or router. And if we read the code here, we kind of can tell that it is sending a request through the middleware and then dispatch it to the router. But before that code is being executed, there's an interesting line here that calls the bootstrap method inside this class. Let's look at what's inside it. And it says bootstrap the application for HTTP request. Let's take a look at what is the bootstrappers. And we see an array of bootstrappers that basically tells us what they're doing. Bootstrap is just another word for setting up the application. So from here, we can tell that the bootstrap method is doing the following task for us. It loads the environmental variables, loads the app configuration, handle exception, register facades, and providers. You might be unfamiliar with the concept of facades and providers, but don't worry. I promise I'll talk more about them in details in a future video. For now, just think of them as the core components in Laravel for the application to work. And the bootstrap method is just helping us to set up these components. So back to our send request through router method. This method will simply set up the application and pass our request through the middleware and the router. So in summary, the handle method inside the kernel will bootstrap the app and send a request to the router through a series of middleware and return us a response. And back inside index.php, we then call the send function to send a response back to the client just before we terminate the application. Now let's take a look at what's happening inside the terminate method of the kernel. The terminate method, based on the documentation here, will simply call the terminate method on any middleware if they exist. So in every middleware, other than the handle method, we can actually define another method called terminate, which will be run by the kernel terminate method. Let's try this out. We'll go back to our cheese middleware and create a new method called terminate. And the terminate method should accept two arguments, the request and response. And all I'm going to do here is to dump by. So if we go back to our browser and refresh, scroll down and we see by as the last element in the response. And that's it. That's a quick overview on kernel and middleware. Key takeaway for this lesson: middleware are functions that run before the request hits the router. The handle method in the middleware contains the main logic, and the terminate method cleans up the app just before the app is shut down. The kernel is responsible to pass the request to the router through a series of middleware. The kernel bootstraps the application by setting up the environment variable in the .env file and the configuration of our app, exception handling, and register facade and service provider. That's it for now, and I'll see you again in the next video. Hey there, Sam. So in the previous video, we talked about there's always a box called the service container attached to our app. And just a quick recap, here's our app, and there's a container attached to our app instance. And as we develop our app, we're going to have a lot of different classes that do different things. And Laravel calls these classes services. However, by default, these services are just hanging around without connecting to our app instance. So to put these services into the container, there are two ways. Either we call the bind method directly from our app instance, or we use the service provider. Let's explore on how we can use a service provider. In simple terms, Service provider is just a class that tells Laravel on how to instantiate a service. For example, suppose we have a service called geolocation, and the purpose of this service is to retrieve geolocation data of a certain location. But for this geolocation service to work, it might be dependent on other classes to work. For example, a map class to approximate the location, and also a satellite class to pinpoint the exact location. So since geolocation is dependent on map and satellite, at the time when we want to instantiate a geolocation service, we might want to create a new instance for each map and satellite and load them into the constructor of geolocation. So our geolocation constructor will look something like this. But here's the issue. Every time we want to create a new geolocation instance, we will have to create a new map instance and satellite instance beforehand, so we can pass them along to geolocation, and that makes things a little bit tedious. And this is exactly where service provider comes into the rescue. And again, service provider is just a class that helps us to instantiate services. In other words, once we set up a service provider for geolocation, the map instance and satellite instance will be automatically loaded or injected into geolocation. In programming terms, if a class instance is loaded into another class instance, it is known as dependency injection. So the keywords here are depend and inject. Geolocation is dependent on map and satellite, and we're injecting them into the constructor of geolocation. That's enough talking, let's dive into the code. First thing first, let's create our services. We'll create a new folder in our app directory called services. And this is where we'll put in our geolocation, map and satellite services. Let's create a folder for each of them and their corresponding service class. Once we're done, let's go to geolocation and we'll implement the constructor. The constructor of geolocation will take in an instance of map and satellite and make them into private properties. Now let's also create a dummy method just for testing. I'll call it search, and it accepts a string argument, which is the location name that the user wants to search. While we are on here, let's create some dummy methods in satellite and map as well. So in the map class, I'll create a new method called findAddress that takes in a string address, and the function will do its magic and return an array of information about the location. Next, let's go to our satellite class and we'll create a dummy method called pinpoint that accepts an argument info, which is the array returned by our map class. And this function will return a geo coordinate, which is the latitude and longitude of a location. I'll just hardcode the values for this demo. And now back to our geolocation class, we'll make use of those two methods that we just created. So in the search method, we will pass the name argument into the findAddress method inside our map class. Once we got the location info, we can easily get the coordinates by calling the pinpoint method from our satellite class instance. And the result of this search function should be the geocoordinates of a location. So we can just return the result of our pinpoint method in this function. And now our class implementation are completed. It is time to create a service provider for our geolocation class. The easiest way to create a service provider is to use php-artisan command. So let's go to our terminal and type in php-artisan make provider, followed by our service provider name. I'll call it geolocation service provider. Once that's completed, and if we navigate to the provider folder inside our app directory, you'll see our geolocation service provider file created in there. Now let's take a look at the structure of a service provider. There are only two methods in it, a register method and a boot method. The register method is where we tell Laravel on how we want to instantiate our class. This is also the place where we load all the configurations that is needed by our class. And here's the place where we bind our class into the service container. Let's try to bind our geolocation service into the container. To do that, we need the app instance. Thankfully, the app instance is one of the properties of the base service provider class. So we can just call this app, and we can call either the bind method or the singleton method. I'm going to go ahead with the bind method because we don't need a singleton in our case here. The first argument in the bind method is the service name. You can put anything you want as a service name, but the best practice is always to use the class name. So I'll pass in the full qualified class name of the geolocation class. And the second argument is where we tell Laravel on how do we create this service. We should pass in a callback function that returns an instance of the geolocation class. And the callback function accepts the app argument just in case we need to access the app instance. And now inside the callback function, let's create our geolocation service. We'll first create a new instance of the map class and also the satellite class. Once we have created them, we'll simply return a new geolocation instance and pass in the map and satellite instances. And now the next step is to register our service provider. We go to config and app.php and put our geolocation service provider inside the provider array. And that's it. We have just registered our geolocation service inside the service container. Let's try it out. We're going to go to our terminal and run php artisan tinker. Tinker is an easy-to-use PHP shell environment provided by Laravel. It's great for development purpose like now, and we'll be using it a lot of time in the future as well. Anyway, let's test if our geolocation service can be resolved correctly. To resolve a service out from the container, there are two ways to do it. One is to call the global app helper function and pass in the container name, which in our case here is the class name of our geolocation class. Hit enter, and it works. We have now resolved our geolocation service out from the container. The second way is to call the make method from an app instance. To do that, again, we can call the app helper function, and by default, the app function will return us the current app instance. And from there, we can call the make method and pass in the container name again. And this resolves our geolocation service once again from the container. Alright, once we got our service instance, let's try to call our search method. And if everything works correctly, we should see our dummy array value return from the function. Hit enter. Whoops, I made a mistake here. Let's try again. And it works. Can you see how easy it is to instantiate any service by using the service provider? We no longer need to worry about the arguments inside a class constructor if we're using a service provider to instantiate a class. And that is a very powerful feature provided by Laravel to us. Okay, let me show you one more thing before we move on. Whatever we return in the callback function is whatever we resolve from the container. So if we return a dummy string inside the callback function of the bind method, the next time when we resolved our geolocation service, we'll just get a string called AAAAA. Let's go back to our terminal, run php artisan tinker again, and we'll try to resolve our geolocation service one more time. But this time it returns the dummy string. And this is what I meant by whatever we bind to the container is whatever we resolve later on. Okay, now let's move on. Let's talk about the boot method in the service provider. The boot method is called after every single service provider in our app is registered. You can put anything you want in there, but it is generally for things like event listener or function calls that requires the other services in our app. So just as an example, if the satellite happens to be malfunction, we might want to send an email to notify the admin using a mailing service in our app. And the boot method is exactly the location on where we can put this kind of logic in. The usage of the boot method is pretty advanced, and most of the time you don't even need to touch it, so you don't have to worry about it that much. And now, here's one more thing I want to talk about before we end the lesson. If we don't put our service provider inside the app config file, by default, Laravel will try to automatically resolve the service for you. That means Laravel will try to do what we did inside the register method on its own. So it will look inside the geolocation service and figure out what dependency is required and inject them accordingly. So if we go back to Tinker, restart the app and try to resolve geolocation again from the container, it will still work. And this feature of Laravel is known as automatic dependency resolution. However, it only works when the service constructor has arguments based on other classes. If we've got arguments that's a string, a number, or other data type, then the auto resolution will not work. Let's try it quickly. If I add a new string argument to the geolocation service and go back to our terminal, restart Tinker, and resolve the service again, and now we see an error because Laravel can't figure out what to put in as a string argument. To solve this issue, we'll need to manually define our service provider and put it inside the app config file, just like what we did before. And that's a brief overview on service provider in Laravel. Key takeaway for this lesson: service providers are classes that instruct Laravel on how to instantiate a service or class. The register method is where we define our class binding, and the boot method is called after all services are registered. We need to put our service provider in a provider array in the app config to activate our service provider. Otherwise, Laravel will just automatically resolve the service on its own using the automatic resolution feature. That's it for now, and I'll see you again in the next video. Hey there, Sam! So in the previous video, we talked about how we can resolve a container instance by using the global app helper function and also a Laravel feature called the automatic dependency resolution. And just for demonstration, I've created a dummy class called playground. And if I want to resolve an instance of my geolocation class here, all I need to do is to use the app function and pass in the class name of my geolocation service, and Laravel will resolve an instance out from the service container. If we don't want to use the add helper function, we can also take advantage of the automatic dependency resolution feature by type hinting or injecting the service inside the constructor. So those are the two known ways that we have discussed so far to resolve a service instance out from the container. However, there's a third way for us to resolve a service instance out from the container, and it's something called Facade in Laravel. In short, Facade is a class that allows us to statically code the service methods. I will show you what I mean. Our geolocation service has a method called search. To call this search method, we first need to get an instance of our geolocation service. However, if we have created a facade for our geolocation service, we can simply call the search method statically. For example, let's go back to Playground, and let's say we have created a facade for geolocation, and we call it geolocation facade. We then can simply call the search method statically from the facade class. And that's it. That's how facade looks like when we actually use them. You can think of facade as a static counterpart of our main class. Okay, now, let's learn how we can create the facade. It is actually pretty simple. I'll create a new class and call it geolocation facade, and all facade must extend the facade base class in Laravel. For our facade to work, we simply need to override one method from the facade base class, and the method is called getFacadeAccessor. And inside the method body, we simply need to return the class name of our service, which in our case here is geolocation. And that's it. Simple as that. We have just created a facade for our geolocation class. Let's try to use our facade. Back in Playground, we'll import our geolocation facade namespace and dump the result of the search method. And let's go to terminal and run php artisan tinker, and we'll resolve an instance of our Playground class. And the result of the search method got dumped inside the console. And that means our facade is working. Now we do have one issue. Although using facade is very convenient, but it is not that friendly on our text editor. The text editor is not smart enough to detect all the methods available to us in the original service class. So there won't be any method autocomplete when we use facade. So what can we do about this? We can insert some PHP documentation to tell our text editor about the methods available. Depending on which editor you're using, you might want to do a little bit of configuration for it to work. I'm using PHP Storm, and the autocomplete works without having me to do any kind of configuration. If you're not familiar with the syntax of PHP documentation, I have attached a few resources, and as always, the link is in the description. Alright, let's go back to our Playground. And now, the autocomplete works. At this point, you might have a question. Should we use dependency injection or facade to resolve a service instance from the container? And here's my answer. They both work and can do the job just fine. It is your personal preference to pick either one of them. I tend to use dependency injection rather than facade, because facade seems a bit magical to me and does not provide auto-completion out of the box. By default, Laravel has a lot of facade provided to us already. And here's a list of facade defined by Laravel. The link again is in the description. They are all very useful facades, and we'll be using some of them in the upcoming videos. Key takeaway for this lesson: facade allows us to statically call service instance methods, providing us a convenient way to call service methods. You can think of facade as a static counterpart of a service class. That's it for now, and I'll see you again in the next video. If you enjoyed the content of this video, don't forget to hit the like, subscribe, and the bell icon for more content to come. It will really help me out. Thanks for your support.